Welcome everyone. Well done on getting through the first 5 modules. I hope you enjoyed them. And now welcome to the capstone project. Right, this is the first one of our seminars. There's a few things we should cover first up. We're going to record these lectures, so if you object, please let us know, and we'll try and cut you out somehow. We'll post them to YouTube as soon as we get a chance so that you can go and have a look at them if you've missed them, or rewatch them if they're that entertaining, which we hope they will be. This session, we'll be introducing ourselves, and we'll try to be present for every one of the sessions. There's a few more people who will be dropping in, and they will also be available to advise you on any particular specifications, or in their specialities anyway. But at the moment, it'll be Ian, that's me, Savash, who's also on, and Yiffy will be joining us probably from next fortnight on. Whenever you need to try and contact us, use the IoT capstone email address. And if you don't get a reply within 2 days, please follow up on that. And we can also talk about any questions you have during these sessions. So I'll introduce myself really briefly because I've said lots before in the previous ones. I'm Ian Murray. I'm the Deputy Head of School for Electrical Engineering, Computing and Mathematical Sciences at Curtin University. It's a very large school. We've got 3,500 odd students in our undergraduate programs, and a large number of research students as well. My background is very much in the electronics, digital electronics, network sensors, what else, embedded systems, assistive technology, dealing with technology solutions for people with disabilities, yeah, IoT, of course, and industrial IoT. Savash, if you'd like to go.
Sure. Well, hi everyone. I'm Savash. I'm a lecturer with the same school as Ian. So same area, embedded systems, small electronics. My research is similar to Ian, lots of assistive technology, looking at smart wheelchairs, hospital beds. My personal research is in tracking human movement, more specifically wrist movement using sensors. I work with children with cerebral palsy. I build gamified rehabilitation type exercises. And I teach a lot of digital design type units at Curtin. So when it comes time to doing the project, if you had any questions about sensors, actuators, the electronic side, the firmware coding, the microcontroller side of things, I'd be able to help you out. And I look forward to hearing what sort of projects you guys end up doing as a part of this course.
Yeah, and I'll give an introduction to a few of the others that will be along. Yiffy is a lecturer with Curtin University as well. His speciality is in embedded systems, networks, artificial machine intelligence when applied to embedded systems. A very useful guide to know if you really want to solve a direct problem on hardware using software. We'll also have, on occasions, Dr. Hannes Herman. He's a software guy, very good on the algorithm side. So if you're looking at efficiency of your program or complexity and other algorithmic issues, he's the man to see. We have Dr. Valerie Maxwell, who is a gun Python programmer, very good in the big data, data science, predictive analytics, those sort of areas. We'll also have David McMeekin, who's a little bit different, even though he's a software guy. Well, David is very different, isn't he, Savash? He's a fun guy. But his area is actually spatial sciences. And where that helps us is if your IoT device that you're looking at, which we'll get into shortly, relies on any location-based service or is to do with mapping, GPS, indoor and building navigation or building locations, he's the guy to speak to. Unfortunately, he recently had a heart attack, so we're taking it very easy on him lately. He is well now, but he's got to take it a little bit easy. If there's anything that we can't answer, and we, of course, don't know everything, nobody does, it's good to contact us anyway, because we can probably find the person suitable to answer your questions. I did mention we're a large school. We're also a fairly large university with around 65,000 students and about 6,000 staff. So if you've got a question on pretty much anything, we can find someone to help you out, particularly in the ag and mining type areas, because that's big in our state. Okay, so moving right along. Just some ground rules to get started. In these sessions, we just ask you, please be polite and respectful of everyone else. Normal sort of rules. If you'd like to say something, either raise your hand or enter your questions in the chat panel. There's a raise hand function within WebEx, so you can do that. If that all fails, then just speak up when there's a silence and we'll get to you. It's a fairly small group this time around. I think we have 14 students, so not a large number this time. How many was it the first time? 110?
Yeah, thereabouts.
Yeah. That was interesting. Got lots of interaction with people. So if you could mute your microphone when you're not speaking, just to make it easier for everyone else to listen in. And video, we like you to have that on if possible, but it's not a demand, just if you can, because it's nice to see who you're talking to. That's the only reason. So now what we'll do, Sebastian, for you, because I can't see who's on, could go around the virtual table, and we'd ask you just to introduce yourself, who you are, where you are is always very interesting too, and what is your idea for this capstone project. If you're not sure, that's great. We can talk about that, find something that you're interested in, and work with you on developing something along those lines. So Sebastian,
Sure.
take us around.
Yep. So I'll start from the top of the chat list. Albert Smith, do you want to go ahead?
That's me. Well, I'm coming from the Netherlands. I did study industrial design engineering in the last millennium, so I graduated in 1995 or something. I work in industry, mechanical engineering with PLCs, and use a bit of IoT also there with VPN routers and beginning of predictive maintenance. But that's not where my interest is for this course. I would love to do something with an more social and health kind of device, and I'm thinking of making something for the elderly people. My father and my mother are at the last stage of their life, and I have seen a lot of things that could go wrong in the retirement home, especially during COVID period. So I hope to design something what would be like a social companion or something that can warn other people if something is wrong. So it will be something in that category.
Yeah, that's really interesting. It's something I can identify with. I've got 3 parents-in-laws that are all getting very frail in their mid-80s, mid-late 80s, and there's a lot that can be done. Sebastian and I are actually working in quite a few areas to do with this, so it'll be interesting to talk on some details. Things like voice-controlled beds, movement monitoring, so we can see if somebody needs to be moved, if they're bedridden, make sure they don't get their pressure sores, sensing their biometric information while they're in the bed rather than having to attach devices to them. It's a really good area to be working in.
Yeah.
And also things like fall detection, tracking their whereabouts when they're in the house environment. We did a couple of projects looking at so mostly for elder care and people who are developing dementia, trying to detect those signs and what sort of things that would lead to. So have you thought about a specific part? Like, was it a specific device or is it more of a companion?
At first I'm thinking of a companion, and that can be with a modern natural language processing like GPT-3 or even the newer ones. Should that be doable? I just found in my box an old Jetson, so that would be a start.
Yeah.
Yeah, I think yeah, there will be a lot about ethical and security issues. Want this is yeah, this is people yeah, who are yeah, not very good at internet and computers themselves. So yeah, it should be yeah, foolproof. So I think it is yeah, quite a challenge, but it is interesting. And yeah, I think mostly yeah, the companion, what I see is especially during the COVID time, there was a lot of yeah, isolation, and yeah, the people got lonely. And yeah, the caretakers couldn't be there 24 hours a day. So yeah, there are lots of times that yeah, you don't know what they are doing, and I couldn't reach them also. So yeah, if I can do something to make that easier, then it would be yeah, a great outcome.
No, that sounds very interesting, and we look forward to hearing about this project more and more, and trying to help you out in any way that we can. We do have a cybersecurity expert within our research group, so when we move along a bit further, if you have any specific questions, we can kind of bring him in or have a chat about some of those cybersecurity aspects, which is, as you said, it is especially important in the health sector. And protecting the privacy of the data as well. No, good. Looking forward to seeing where we can take this. Moving on to the next person. By the way, I'll mention something. In Australia, we are fairly casual people, so you'll see me refer to Ian as just Ian rather than Professor Ian Murray. So yeah, you can feel free to just call us by our first name. So next person, Mr. Albert Magnus. Go ahead, please.
Hey, hi. Sorry, did you say my name? Sorry.
Yeah.
Okay. Yeah. Thank you. Yeah. Well, I'm Albert. I'm from Zagreb, Croatia. Well, my nickname is just the same as Idek's name, so it's, yeah. Please, you can call me Albert. Those Albertus is just a old guy from 12th century, the Bishop of Germany. Anyway. Okay, so for the my education, well, I went in the high school. I finished robotics. Then after that, I went to the Maritime University. So I end up being a seaman, and been doing that for the next 10 years or so. And now I have decided to change the profession, let's say. So I went to another last year. I have joined the University of for Computer Science as a programming, just a basic programming curriculum. So that will be shortly about me and my professional life. So for the ideas of this capstone, unfortunately I don't have any specific idea that I would want to go, but what I have is a point of interest. I have 3 ways I would like to go, one of the other. So the first idea was something in connection with agricultural systems, to solve some problem there, as you have defined, like a soil testing. The next one would be also like a health issues, but more in the way of occupational health issues. Something similar as the soldier spine that was in some of the courses about the back problems and that in the occupational health. And the third way, maybe I could connect the cybersecurity issues and now the new technology of autonomous ships that would be something connected to my profession as a seaman. So I could maybe connect those two knowledges together. So that would be my ideas, but not exact one. I don't have it yet. Maybe you could help me so to decide and to pinpoint some device.
Yeah, it's three very interesting areas. We do a lot with agriculture here as well, both with animals and growing stuff. I'm not in agriculture myself, but it's a wide open area, and there's a lot we can actually do in that. Not just in the soil or the counting animals. We've got a really interesting one coming up at the moment that's looking at having a device on the watering area, the windmill, on one of our cattle stations. The cattle station is 2.5 million acres, 4 million acres in size. How many cattle did he have? Can you remember, Savash?
A lot.
Yeah, a lot. It was in the thousands.
Yeah.
The driveway itself is 120 kilometres long. So just to get from the road to the house is 120 kilometres. So they've got an issue with having cattle scattered over the 4 million acres and being able to see what they're doing when they're being watered. They've got the additional problem of dogs, donkeys and camels getting into the watering areas and disturbing the cattle. They actually do cause a lot of problems. So they want to set up an automated method of opening and closing gates to allow the cattle in and keep the donkeys and camels out. Big communication problem. There is no telephone coverage out there. We miss a lot of Australia with no coverage. And of course, you've got to go several hundred kilometres back to the homestead. So lots of interesting issues in that one. And working on things similar to that's also a good way to go.
That sounds very, very interesting. So are you thinking to put some like artificial intelligence who would recognize the one animal from the other?
Yes, it must be able to identify what is a cow, what is a kangaroo, what is a donkey, what is a camel, what's a dog, what's a person.
Ah, nice. Okay, interesting area.
Yeah, agriculture is very interesting actually. We've got quite a few projects there, which we'll talk about as we go along.
Yeah, and then there are lots of activity and using IoT devices in space, whether it's the stuff that Ian mentioned, or it's actually using IoT devices to monitor the degradation of a plant's life, how often, how long does it take for a particular bacteria to be expanded throughout the field. It's something that we've kind of started looking at, so using machine learning and image processing and taking pictures of plants and leaves and looking at them throughout the life cycle of the plant to see if there's a bacteria there, how fast it's growing. So those types of things are very, very interesting. So it'll be interesting to see what sort of new approaches we could have in terms of a standalone device. There was one that we were looking at, Ian, I'm thinking of the cattle eyes project.
The other things you could look at is for particular conditions in animals out in the field. So you can have an array of cameras out in a paddock. And the one we're actually looking at is for something called pink eye. And it's an eye infection that cattle get. And it means that you can't send them to market. So we're working on ways of identifying this by cameras just out in a paddock and looking for symptoms of pink eye, such as the tear streak that they get, and then identifying which cow it is, number one, and separating that out when you bring them in for whatever you need to bring them in for.
Mm-hmm.
And of course, we had that dairy example that we used throughout the courses.
Yeah, I remember.
Yeah.
Nice. So in the next week, I should decide probably
Yeah, it'd be good to make sure you've got something within the next week or so that you can get started. Um, More than happy to have another chat with you offline with this. If you just email us, we can set up a time. If you need to go through anything specific, and that goes for everyone, you can email us via the IoT capstone email address. And because there's 14 of you, I think we can probably set up a time to have a bit of a chat when needed.
Okay, nice.
Who's
Okay.
next, Smash?
Thank you.
All right. Thank you. So we'll go to the next person, Ali Bakabas. You want to go ahead, introduce yourself?
Can you hear me?
Yep, all good.
Okay, so my name is Ali Bagawast, and I am from maybe a new place for you. It's Saudi Arabia. I studied a bachelor degree in Japan. Then I came back to my country, and I'm working in oil and company, gas, yeah, oil company. It's called Saudi Aramco. So yeah, I'm currently working there in the IT department.
Okay. Do you have any
So,
idea of?
Hmm?
Do you have an idea of what you'd like to develop?
Yeah, so in our team we work on smart cities specifically. So they want to ride the fourth revolution, digital revolution trend. So they have many areas to develop, and our group we handle the smart city projects. So what we have done so far, we have done a lot in the past 2 years, like facial recognition and smart street light or traffic lights. I worked myself in a project like they use smart power meter and smart water meter, irrigation, all of these use cases like connected in a unified IoT platform. So yeah, so I haven't thought of an idea yet, to be honest, but so our scope is smart city in general.
Yeah, it's a big area of research and development at the moment. We've had students who have done things like intelligent garbage bins, which is a major save of resources. If you can imagine, you don't have to go to a bin until it's actually full to empty it, so you can take shorter routes with the vehicles. If they are giving off noxious gases, they smell. You can pick that up with gas sensors and notify the centre place that needs an early emptying. You can look for things like water getting into them. If somebody knocks a bin over or it's damaged, you'll be able to tell and do the repairs. And it just creates massive efficiencies just looking at the bins alone. When we start to look at everything that cities provide to their citizens, there's a huge array of things that can be developed to automate, streamline, and create efficiencies. So, really good area, the smart cities.
Yeah, for garbage bins, yeah. One time I had like I hear this idea and I saw one of my colleagues present this idea to the management. I'm not sure why they didn't implement it, but yeah, it will just suggest a route for you to collect the garbage instead of like going to every bin and check it.
Yeah, you're going to a bin that's already empty or doesn't need empty. You're wasting all that fuel, and more importantly, you're wasting this employee's time having to go out and check that bin. And
Yes.
well, in Australia and many other places, salaries are the biggest expense that you have in councils.
Mm.
There's a good one if you want to do that. It's
Okay. I will
have a
keep
think.
this in mind.
Yeah. But there,
Hello?
Oh, Ian, we lost your audio, your microphone audio. Did something get unplugged, maybe? No? Can everyone else hear me?
Yeah, I can hear you.
Yeah. I think microphone might have got out in. You just hear some funny robotic noise coming in. Still not. But no, it's an interesting area, Ali. And by the way, we do get a lot of students coming in to do PhDs, especially in electrical engineering in that power area from Saudi Arabia, using that government funded scholarship scheme that's going on at the moment. And
Yes.
we actually have a couple of people also coming in to look at IoTs, specifically in smart cities and looking in the area of tourism, that type of things. So
So
it's,
I
it's
think
interesting.
in the past 3 or 4 years you have fewer students. Is that the case?
Yeah, it's been interesting with COVID, but uh, well, the interesting thing about the PhD is, especially that first year, you're spending a lot of time doing research and looking at literature and that type of thing. So we managed to attract a couple of people doing that part of their project and that part of their PhD remotely, and then kind of getting in to do the research now. And then, of course, Ian and I have a lot of experience in teaching online courses. So with COVID, we were lucky. We knew a lot of good simulators, especially in this area of IoT. There are lots of cool things that we can use. But no, it's definitely been an interesting time in these past couple of years.
Okay, it's good to know.
Yeah. All right, good to hear from you. Ian, by the way, we're still getting the funny buzzing sound, FYI. Oh, don't have any audio. Oh, can you hear us, Ian? Yeah, okay, all right. So I'll move along to the next person. Arsalan, you want to give us a quick introduction and tell us what sort of area you've been thinking about?
My name is Ashlan and I'm from Pakistan. I recently graduated in my master's in electrical engineering and I'm working as an embedded software developer, mostly focusing on the IoT domain.
Okay, so have you thought about a project area that you're interested in working or
Yes, I was
any ideas?
actually thinking about a problem that we have here in our locale. So the groundwater here where I live is quite contaminated, so we can't actually pump groundwater directly. We get municipal water, but the times are not fixed. So sometimes they give the water at 4, sometimes 4:30 or 5, like that, for example. So we don't have any idea when the water will come. So we just keep our pumps on and hope that it will fill our water tanks. So what I was thinking, I can create a device that will detect the pressure in the water pipes if the water is available, and then turn on the motor pumps accordingly. So it will save a lot of energy.
Interesting. Yeah, that would definitely be an interesting area, like looking at that water management side of things. So is it you'd be looking at what sort of areas are missing water? Because sorry, your audio got cut out a bit. Or is it looking or are you looking at water pollution?
Actually, it's more house water tank filling.
Oh, household tank filling. Okay, got you. All right, no, that's interesting. I remember in one of the apartments I lived, there was always the problem that we didn't we never know whether it was the tank that required filling or just the water was out. So we had someone having to go to the rooftop and look inside the tank to see if there's any water left or not, or is it just city's water that just got disconnected? Yeah, no, that's an interesting thing. Uh, uh, that we can have some basic sensors looking at the level of the water and then having that transmit some information outside. Okay, no, cool. Yeah, that's the
Can you hear me now?
yes, all good.
Swap
Yes,
microphones.
right.
Also on the anything to do with water, adding in the water quality, water temperature, salinity, looking for the turbidity to make sure the water is clean, usable, drinkable if it's meant to be drinkable, and that can add quite a bit to the project. Give you plenty to do.
Yeah, especially yes, if the main purpose would start at just looking at the water levels, but once you have the sensors there, you might as well have added a couple of things, a couple of other things as Ian mentioned, and provide that information as well. But no, it's a cool area, and we look forward to seeing where you can take it.
Yeah. Also tying into things like the weather forecast if you're using the tank for rainwater capture as well. So you don't need to pump water in if there's a rain predicted for that next day or in time before you'd empty it. And you could base that on the long-term usage of the water. So you'll know how much you're using over time, which you can learn. And then only pump water from the mains when you're not going to capture enough via normal rainfall.
Okay. Yes, I would add this down. Thank you for the suggestions.
All right, cool. Thank you very much for that, Arsalan. We look forward to see where you can take this project. And of course, last but not least, Harun, you want to give us an introduction?
Hi, I'm Harun. I'm from Turkey. I work for a French company called Raymond. They're the fastener supplier for the automotive sector, like all the BMW, all the big car companies. And mostly what my department do is the prototypes that, depending on the customer requests, it's for the fastening or the quick connectors for the fluid transmission. And what we do basically, it starts from simple mechanical pick and place applications up to the fully automated robotic solutions. And one of the biggest, let's say, missing part in our company is the new technologies such as the IoT or the data collection and manipulating this big data into making some predictive and preventive maintenance. This is one of the top requests from the customers coming to our way. And my job is to turn these ideas into prototypes. And previously, the companies, all the other engineers use the Siemens PLCs or all the big modules. But what I want to do is, or what I'm doing currently, is trying to turn all these devices into smaller embedded systems, which makes them cheaper, easier to manipulate, and let's say harder to copy. So in the end, we have very different type of products. And well, what I want to do in this project is, of course, something related with the automotive industry. It would be mostly based on the data collection and what to do with this data. For example, to get the state of the machine and give us some feedback from the machine, or let the machine take some of the basic decisions by itself. For instance, when to make a simple oiling a certain part, or place an order of a specific part that's going to break down soon or gonna need a maintenance. So at the moment, suitably, I have around 6-7 projects that I can use in this capstone project. So I'm not going to go into detail for all of them, but basically what I will want to do is to get this loads of data, collect them, filter them out, and turn them into readable first charts, and then to let the machine make the machine able to make its own decisions, or to give feedback to the humans, so it can be usable.
I think you've just summed up what the IoT should be.
I'm sorry, I couldn't be more specific. But okay, more specifically, I can say that, for instance, I have a machine that's assembling a quick connected part with over 150 sensors that's running simultaneously. And one of the requests is that this machine needs constant repairs. It has oil leaks somewhere. It has some parts that's getting worn out. And we have sensors that can detect it, or we can measure the vibration, for example, on one of the motors to check that if there's a big change on it. But these data is always being checked by humans. So I want to automate this process.
Yeah, no, that sounds really interesting. We've got a few things. One of the issues you might want to keep in mind is the security of this, because in a lot of cases, we found anyway that the process control or the operational technology really doesn't look at security sufficiently. And if people can inject wrong information, it can cause all kinds of issues. Did you want to mention, Savash, not Sphere, what was it? The Microsoft.
Yeah, Microsoft Sphere.
That was Sphere, okay.
Yeah. The cloud where yeah, so like we had a project with one of the industrial companies here looking at connecting one of their assets securely to the cloud using the Microsoft Sphere platform. And we did that as a summer project with them in a kind of a small project collaboration. And it was lots of interesting discussions in terms of the cybersecurity aspects and being able to connect an asset to the cloud, the implications of that. And then once that secure connection is there, the different possibilities that it will open up, especially in the area that you've mentioned, so that predictive maintenance, and especially became a very hot topic during COVID, because people just didn't have the resources to be able to send staff to check on these equipment, and so it's kind of given a bit of a boost in this particular area. And I'll just mention as an aside, if the project that you end up choosing ends up being tied down to your company, and you didn't want to discuss the technical details of that in this kind of public online form, we can have a separate meeting if you wish, and we'll make sure we'll kind of remove the details of your project from the pure assessment aspects of the unit to kind of protect your IP and the ideas.
Yeah.
If you did end up going down that path, that's an option that we'll have.
Yeah, we've done
That
that.
would be great, actually, because before I started this, I had to consult with my, of course, managers, and that was the first thing they told me. First, the cybersecurity, that I need to make sure of anything that I do, and the IP, that I need to be careful on what I reveal.
Yeah.
Of course, I can always manipulate the contents of the machines or what they do. So, and one of the beautiful things about the automotive industry is that almost any solution that we do has to be unique, because there are so many different approaches.
Yeah, we've done this previously as well, so it's not something new. We've had quite a few of the projects that actually gone into commercialization, and we do respect the intellectual property. It remains with the student, so that's not an issue for us. Anyway.
That's great.
And then I would say with that first assessment coming up, the Canvanizer, because that is peer assessment, so you'll get to see other people. They'll see your project. So in your case, what you can do is you can just email your Canvanizer directly to us. So that means only the academic staff would be able to see that, and then it wouldn't get publicly shared with anyone else. So when it comes to submission, you'll just submit a statement saying this has been privately submitted to the assessor, something like that.
Last but not least, I would like to talk with either or both of you at the end of this course.
Sure.
About a technical issue also.
Yeah, I was. Did you send us an email? Is it about IoT 3 and 5?
Yes.
Yeah, just saw that email. As you were speaking, I forwarded that to our technical staff who take care of the edX courses for us. So
appreciate it.
as soon as they get back to me, I'll let you know.
Thank you so much.
No worries. Well, Ian, that was the last one. if you want to
Okay.
go on.
All right. So sounds interesting. I think we've got some fairly good options there for projects. But we will take these further with you. And as I've said, don't hesitate to email us if you want to know anything or ask anything. From here on, the purpose of these meetings is very different to a normal MOOC. We've got not a large amount of material up on the edX page for you to go through. It really comes down to these sessions that we're having with you to assist you in developing your prototype. We want it to be interactive. We'll start off with a bit of an icebreaker and a presentation on a related subject. What have we got next week, Savash? Which one is it?
I don't think next week we're
Oh,
covering
next
the
one, sorry.
Cambernizer stuff before we get to the individual topics, Cambernizer and the
So we'll be
development.
going through Cambernizer, but we'll talk about, PCB production and prototyping. David McMeekin will come in and talk to you about the spatial science side of things and GPS. But we really do want these sessions to be you talking to us, telling us how you're going, asking questions, general discussion. So very different to a traditional, if you could have a traditional MOOC. It really is interaction. So you've met some of the teammates. Hopefully in the discussion board, you'll meet more of the people who couldn't make it tonight. And with your idea, it pays to be very ambitious and very creative with what you're coming up with. We hope to get most of these to a proof of concept. So it can be a cut down version of what you'd eventually like, but it is really good to be ambitious, and that allows you the opportunity to investigate unorthodox or unusual, novel ways of doing things. I suggest that you make a list of questions for us and for your teammates, the other people that are in the course with you, and raise them during the discussions or put them up on the discussion boards, so we can get a bit of a back and forth going on what you're developing. All right. So that's really all we wanted to cover tonight. We've still got 15 minutes or so if anyone has anything they'd like to add. If you'd like to hear any interesting yarns of our past courses, we've had some very, very interesting projects. My favourite, I think I'll do this one again. Savash probably gets sick of hearing it. One of the projects we had was by a vet, and his idea was to determine the colour of horse mucus, because that actually has a direct bearing on the health of the horse. So the longer story of it is he was actually developing a monitoring system for horses, but one of the major aspects was examining horse mucus. So ideas can be rather out there, left wing, and it does make for an interesting project. We've had several that have been commercialised. One of them won a national prize, innovation prize in I think it was Colombia, was it?
Yeah, I think so. Just with the shower head.
Yeah, the shower head one. Monitoring the temperature of in-shower head water heaters. I don't know if anyone here has experience with those. It's a scary thing to me. But they actually have the heating element inside the shower head and power cables running up the shower head and into a plug in the wall. I'm not sure that's a good idea, but they aren't actually checked for temperature, so they can be erratic. They can scald people. They can burn out. And he developed a device that would monitor this and inform the person if something was going wrong. And they could also preset temperatures and other things. So there's been a few good ones. There's a few we can't mention because they are going commercial. One in Western Australia that we're helping develop still, and that will be hopefully implemented in the next 6 to 12 months in maybe 10,000 odd homes, I believe.
Yeah.
There's two of them. We've got two of them, but yeah.
Yeah.
You got any you'd like to raise?
Yeah, there was an interesting one looking at an automatic bird feeder. We had one of the ladies who did the course. She was interested in. She had she had a big backyard, and she always had a lot of birds in there. So she had the idea, what if I ended up building an automatic bird feeder that would start feeding these birds, and then it would inform me when I need to go and replace the seeds in there. So that was an interesting one. Off the top of my head, we had a couple of interesting agriculture ones looking at different scales of implementing IoT. So we had one that the person had this is an interesting one. Remember, of course, it was a French guy. He wanted an IoT device to check the quality of wine. So when you pour it in the glass, it would analyze it and tell you what sort of temperature you should be eating this particular wine, and then what sort of food does it go with. That was an interesting, very interesting project. But yeah, lots of things small like this, and then also big commercial ideas. And then we've even kind of gone down the path of continuing the collaboration of that project with research. So one of those ideas that I ended up writing a paper with them, and we can find that in my Curtin staff for a while. We had someone who heard that I work with children with cerebral palsy, and they had a child with cerebral palsy. So they were looking at developing a device, inertial measurement unit connected to a microcontroller, to look at the head controllability of their son's head. Because with cerebral palsy, one of the attributes is we want to measure how accurately they can hold their head, and then what are the effects of that. And she ended up developing that device throughout this course. And then once she was done, we actually remotely worked together, and ended up publishing a paper. And it's an open access paper on MDPI sensor. You can look it up to see where that project ended up in. So collecting sensor information, doing machine learning, classifying the different positions of the head. So
Is that
interesting ideas.
in Sweden, isn't it?
Yeah. She started. I think when she did the course, she was a master's student in Iraq, and then she ended up using some of that project to get a research position in Sweden, and then now she started her PhD over there. So lots of interesting directions. Yeah.
So has anyone got any questions for us? Anything they'd like to raise? Anything at all?
Yes.
Karan?
Yes.
I would like to ask how much of the projects that we do can depend on the, let's say, external tools. For example, if I want to make a IoT connection, can I use Arduino for the embedded system instead of developing my own, or can I make this connection to a certain website that already provides the IoT connection in between? Or do I have to set up this on my own on a server as a computer?
Never reinvent the wheel.
Perfect. Thank you so much.
The idea is that if there is something there that you can legitimately use it.
You have just talked like my boss now. Perfect.
No, everything's built on other people's work. It's things have become so complex. I doubt anyone could now say write an operating system from scratch. It has to be built on something else. And the IoT is ideal for this because there's such a wide range of bits and pieces out there that you can work on a systems level and put those pieces together. If it turns out you end up with something that has huge market demand and it's worth redeveloping your own boards for, go ahead and do it. But in this case, use tools that are available, use platforms that are already available. If you're doing any machine learning, use something like TensorFlow, which packages everything up nice and easily for you. Even if you've got difficulty accessing physical hardware, there's lots of simulation tools and we can help you find the right ones for that. And you can do it all in simulation for this course. It's really about the process of being able to develop something, having the knowledge, and this is something I should have mentioned, so having the knowledge to talk to the people who may be more expert in something than you are. And in the IoT, that's kind of critical because we're dealing with health professionals, agricultural scientists, miners, metallurgists, a vast array of people. And these people know far more about what we're trying to achieve than we do, right? So we use their knowledge to build what we know about. And that's always a good way to go. So if you don't know something, see if one of your teammates do or ask us, but use their ability or bring information in from outside and look at the building on your strengths within the project.
Crystal clear. Thank you.
Yeah. Ian, by the way, your video got turned off, I think, if you meant
Of course it does. As soon as you stop sharing
Yeah.
screen, it stops sharing video.
Yeah. And I'll say one more
Making hand movements.
just a quick note that we may get people who don't have a technical background in the course, and I'd say that's completely fine, because then your project and the way you end up designing that IoT device can be focused on the actual specifications and putting that initial design of that idea together, rather than focusing on the low-level embedded system or the electronic side or the communication protocols that involved. And we've had that in the past where we had people just with complete business backgrounds doing the course, and then their project ended up being putting a business case forward for what they wanted to do, and then we ended up discussing throughout the course and with other people in terms of what sort of electronics they wanted to use, and them finalizing that specification list. We have Ali, you have your hand up. You want to go ahead? And did you have a question?
Yes, it's just asking for advice
Sure.
in the way forward for me. I'm just beginning the journey of my IoT. And my background is electrical engineering. So I wanted to learn embedded systems. So I bought Art of Electronics book. It's a big book.
Horowitz, yes. Horowitz.
Yes.
Yes.
Yeah.
Well.
So it's basic electronics, starting from transistors, op-amps, and all of these electronic circuits. But my goal is to be an expert in the hardware of IoT, and maybe general knowledge in the other areas, maybe cloud services and networking. But I want to get deep into like the hardware itself.
Yeah.
So am I wasting my time like learning this huge book, or should I what's your opinion on
No,
my
that book,
web?
I wouldn't start at that book and read from page 1 to page 1,000 and whatever. Use it as a reference. So when you need to know something about setting up a transistor as a switch, go and look up that section. But it's a very, very, very good book, very readable. It's technical enough without being overly theoretical. So it makes a great reference for these sorts of things. One thing that's happening nowadays, and some of us here already know this, there's not a lot of electronic design that's going on anymore. Just about everything is buying an off-the-shelf processor of some kind and interfacing to that. So you might do a little bit of electronics to get your signals in, to amplify it or do some signal conditioning. And then at the other end, you'll have some electronics to drive the mechanical parts that you want to drive. But everything else is done in software on the board itself. So concentrating more on the software, but from an embedded systems perspective, is the better use of your time, more than likely. But understanding about signals and signal processing is also crucially important. And we can concentrate on that in this capstone, if you like. So pick something where we're reading in different forms of sensors. We'll show you how to process that sensor data that's coming in, particularly analog sensor data, and process that, and then output something that will perform a function, so that you can do the interface circuits, but more importantly, you know how to deal with the signals that are being produced from different sensors and how to handle that in a programmatic way.
Okay, so isn't that like Arduino or something, or like
Yep, Arduino's great. It has drawbacks, which I think we mentioned a few times in the course, but it's a very good processor to learn on. It's cheap. It's got lots of libraries, so that again is not reinventing the wheel. You can use someone else's code legitimately, so don't write it yourself. But when you get into more specialized applications, you want to start looking at specialist processors. But the Arduino is a good way to start.
just for POC or something.
Yeah, something like the Arduino Mega is good for that because you have sufficient I/O to make up for what the PLC is doing.
Okay, so what's your advice on the best time? You said like embedded systems. I should go directly in embedded systems. So do you have any material recommendation or something, or way of learning?
I'll hand that over to Savash because he's the most current person that teaches all of our embedded systems unit.
Yeah, so well, look, with embedded systems, I think the easiest way to start is look at an architecture book, right? Something like we use MST430 as an example, right? What you can do is, and I'll send you a link with a couple of suggestions of what things you can read at your own time. But basically, if it's any book with embedded C and embedded programming in there, because what that would take you is it will teach you this is the architecture for an embedded system, and it will teach you to think about programming from that hardware point of view. For example, one of the things that we do as an embedded system engineer is you end up coding in C, so interacting with sensors, registers. Then it gets time to a point where you want to specifically manipulate memory, right? To give you a very basic example of that, imagine you're monitoring a valve somewhere, and if the pressure goes above a certain degree, you want to turn off the valve or you want something to happen, right? So that means inherently you need to write the code that's stuck in an infinite loop that's constantly monitoring that behavior. Now, that's the problem is if you have an infinite loop, that means you're constantly consuming power, you're constantly using CPU cycles. So what we have to do is we put the program in what we call a low power mode, and then once that particular event happens, we cause an interrupt to wake the system up, then go to a different part of the code, handle what we want to do, so ring the alarm, then go back to sleep. So that the process that I just mentioned, it requires you to be able to have access to the low level hardware of the system and be able to manipulate the memory. So then you'll know, okay, this is where I can go back to my program and continue being in that sleep mode. So what we do is we write in C for those particular parts, then that's where we get assembly language involved, just for that particular memory parts of the code. So that type of information, you'll really have a good understanding of it if you look at an embedded system, embedded C programming code, because that will take you to exactly these types of information. And that will give you the understanding, okay, this is how I think about it. And the difference of comparing to doing embedded C and embedded books, and as I said, like I'll give you a couple of suggestions, is it's programming, but it's not just pure abstracted out programming concepts. You're learning programming, say you'll have an understanding, if we say shifting is multiplication or division, what exactly is that? Because you'll have an understanding that, this is the register, this is how it's built. So when I do a shifting operation, that's what's happening. Like if you have that in your mind, then you will have a much, much deeper understanding of embedded system. You have a better understanding of what does it mean to write an optimized code for an embedded system. And everything you're doing, there's a hardware thing that's happening. So it's not abstracted out concepts.
Yeah, there's a philosophical difference between computer science and engineering software. And you'll find this Croatian, Albert. When you're studying computer science, it's all about readability, maintainability when you're writing code. In engineering, we write code for efficiency. So we may do things that look utterly crazy to a computer science person, but we're doing it for the reasons of either reducing memory footprint, reducing power consumption, speed of operation, so that we can actually use a cheaper processor. And that's how we design things. From the computer science perspective, it's very different, because you want to be able to maintain code. With an embedded system, many times you'll develop something and you will never ever update it. So we're not worried about the maintainability or those aspects. So it's slightly different, well, very different, but you should really try and understand both, because if you're writing the user interface or the dashboard for displaying the information that you're collecting, that is always done in a higher level language using computer science principles. Yes, Albert.
Okay, yeah.
Just a short question. So when we are talking about the code, how low we should go? Like the assembler level of coding in embedded systems, or
Only if you have to.
Only if you have to, yeah.
My favorite language is assembly language. I used to write diagnostics for mainframes when I was young and could still concentrate. And that had to be done in actually machine language, so that you knew within the discrete component CPU, you were setting a pin high or dropping a pin low, so that you could actually run the diagnostics through the discrete gate CPUs. Is that useful for most people? No. There isn't a need. You've got most of the control you need in languages like C. However, knowing how assembly language works is always beneficial, because it gives you a better understanding of what you're actually creating. So when you go printf, you know what you're actually doing with that library call and how inefficient it can be.
cool.
Yeah. Yeah, just a little tidbit maybe for you specifically, Albert. So we have things that we call intrinsic functions in C, especially in embedded C, where these are this is C code that gives you access to that low level. So it uses an assembly language frame around it, that for those parts of the code that you do need to have that low level access to memory and that low level interaction, you use those intrinsic functions to handle that part of the code. And then for the rest of it, because you don't need that low level, you can then go up to C, or even in some cases to go higher to a Java or something object oriented. It's about the task that you're doing, what level of control you need, right? The more optimization you need, the more power consumption becomes critical, the more you need to use low power mode versus, because of course there's always a trade-off versus how much power you're using or compared to how much performance that you're going to have. Because, well, as soon as you turn off some of your peripherals in your system, well, you're not as responsive. And then there's also consideration of the amount of time it will take your system to wake up and respond to that. So it's all very interesting, cool parts of it. So as you can see, I'm getting excited about it, because that is a part of the embedded system that's interesting to me. Because when we say, oh, computers are ones and zero, when you look at it from an embedded system point of view, you know what exactly that means. That means that 1 and 0 that's inside your register, that is what gets translated to that is your machine code. That's what gets translated to an assembly code. Then that assembly code gets translated to a C code to a Java, and so on, or to an object-oriented code, and so on. So yeah.
You just reminded me, probably the best book for understanding computer architecture is one written by Hennessy and Patterson.
Hennessy Patterson, yeah, that one.
It's chronic overkill for this course, definitely. And it's a big, thick book like Horowitz and Hill, but it goes through and it teaches you how to actually design a CPU. So it's a very interesting book if you're into that sort of thing.
Yeah.
And of course, that means creating the instruction set, which means you're writing your own compiler for assembly language.
Very cool. All right. We're about to, I think, wrap things up, Ian. It's 6 past 9 here.
Got any other questions? All right. Wonderful to meet you all. Don't be strangers. If you do want anything, just shoot us an email, and we will catch up with you in 2 weeks. Have a good Easter. And I'll stop the recording now.